All right, guys, last video for today, and we've got some examples of rewriting expressions in different ways, and we've got an equation to solve. Okay, so first part, express each of the following in terms of a single trig function. All right, so basically what this means is we have to write everything in terms of sine, cosine, tangent, some trig function. If we look at the first one, sine 4x, cosine 4x, okay, so those are the same. And we've got this 2. So this looks like 2 sine u cosine u, but that's with u equaling 4x, okay? So this, if you guys recall, this is equal to the sine of 2u, all right? So for us, the answer is going to be sine of 2 times 4x, which is 8x. All right? Next one, cosine squared minus sine squared. So if I see that, I'm thinking that that's cosine 2u. So I'm going to write that just as a reminder that the cosine of 2u is equal to the cosine squared u minus the sine squared u. Okay, and for us, u is equal to a half a. So our answer in this case is going to be the cosine of 2 times a half a, which is the cosine of a. All right. Last one. Well, this looks similar to A, but the thing is there's no 2 here. All right, so I'm going to start with that identity, double angle for sine. And we know that 2, I'm going to write a different way though. 2 sine u cos u is equal to sine 2u. That means if I divide by 2, that the sine of u cosine u is equal to the sine of 2u over 2. And now, right, what we have here, sine u cosine u, is the same as that. It's just that u is equal to 5 over 2x. All right, so u is 5 over 2x. So therefore our answer is going to be, and I'm going to write a half, right? And so instead of dividing by 2 here, I'm just going to put a half in front. And then we have sine of 2 times 5x over 2. So that's really 1/2 sine 5x. All right. So yeah, and just so you guys know, I'm using this u because this is a substitution variable that you will use a lot when you get to calculus. So you can really do it with any variable, but u is traditionally the substitution variable. Okay, last page. By the way, before I'm thinking about it, or while I'm thinking about it, the homework's out of the packet. Right, so you have some questions from page 13 and some questions from page 19, and we'll post those in Classroom. It's a lot, but I think you'll need to practice with this, okay, if you want to really be ready for next year and for the end of year exam. Okay, the example here says find the solution to the equation blip where x is between 0 and 2 pi. Okay, so we've got one full unit circle. We're finding a particular solution. I know I've used that wording before, not a general. So what that means is we have finite answers. We don't have a formulaic or way of expressing infinite answers. We're going to have a finite number of answers. And we want exact values. Okay, so let's copy this down. So 3 sine squared x plus cos 2x minus 2 equals 0. Okay. This is a little tricky because number one, we've got 2 different trig functions. I've got sine here, I've got cosine here. Okay, if this was a sine function, that would be a little bit better because then we have all the same trig functions and we can try and factor like before. So that's one thing ideally we want, is the same trig function. Also, we want the same argument. And what I mean by that is here we have the sine of x. Here we have the cosine of 2x. So this is a problem for a couple of reasons, right? It's not a sine, and it's not the same argument. And we could try and change either of these, but this is pretty simplistic, right? So I prefer to change the cosine 2x because mainly the argument is 2x, and I want to make it x. So we've got some options here. If we recall, we know that cosine of 2x is equal to cosine squared x minus sine squared x. Okay, that might help us, but what I don't like about that is we still have a cosine squared, and ideally we could write everything with just sine or sine x. So this is also equal to 1 minus 2 sine squared x. And this is what I want to use, right? Because this is, the argument is x, right? This matches this, and it's also sine squared. So I'm going to substitute this in right here after I highlight it. Okay, so this equation is going to become 3 sine squared x plus 1 minus 2 sine squared x minus 2 is 0. And now I can group stuff together. 3 sine squared minus 2 sine squared is 1 sine squared. So I've got sine squared x. And then numerically, I've got a 1 minus 2, that's negative 1. When I move it over, it becomes positive 1. So, got sine squared x equals 1. Okay, that means that sine x can be plus or minus 1. And if I think about where that can happen on the interval 0 to 2 pi, well, that's just two places. One is pi over 2. That's straight up, right? So right there at pi over 2, the sign is positive 1. And then down here at 3 pi over 2, the sign is negative 1. Okay, so believe those are only answers. Okay, now let's go back and check it just to see. Let me check it here. So we'll do pi over 2 first. So 3 times the sine of pi over 2, that's 3, plus 2 times the cosine of pi. The cosine of pi is negative 1, minus 2. Check, that works. Let's check 3 pi over 2. Sine of 3 pi over 2 is negative 1, but squared is positive. So that's 3. The cosine of 3 pi is also negative 1 and then minus 2. So yeah. Okay, I guess that's it. Don't forget about the homework. Don't forget about the formative quiz that you have also today. That'll be your last quiz of the year. You have one test and then a culminating assessment. So got a lot to do, but you guys are almost there. Okay, so hang in there and give us a shout out. Sorry, not really a shout out. Let us know if you have some questions.